First and foremost, I do record my lectures. This is just simply for ease for you guys. If you guys are sick for some reason, I just highly recommend you don't need to go to a doctor or show me a note or anything. Just stay home and don't get your other classmates or me sick as well. If you have to miss an exam because you're sick, let me know, and it's really no problem whatsoever. I'll record my lectures and I'll try to get them up to you guys as soon as possible. The lectures are also there just so simply you can, review a bit better, so you don't have to panic about note taking. The whole, oh, he wrote a million things on the board and he just erased it before I had a chance to get it down. So this is to avoid all that. That's the unnecessary stress. I'll be hosting it on YouTube. And I should have added everything on YouTube on my channel, so that way you guys can just simply watch it. And since it's on YouTube, then if it's down, it's not my fault, right? I'm letting Google be responsible for handling everything. So this course will go over a lot of things in 6 weeks. In full disclosure, we've never run data structures during the summer here. The reason we're running it here for the first time is kind of complicated. One, because I volunteered, but also because we're running it in the Japan campus simultaneously, and we weren't sure how that's going to work out. Now the campus in Japan, they run a 10-week as opposed to 6 weeks. Their 10 weeks also includes their final exam period, so they have a bit longer to go, a bit longer to teach, but basically our semester starts 2 weeks before the Japan semester, so I can report basically if there's issues teaching this during the summer, I can let them know. Because this is a very intensive course. If you stumble, it might be a bit hard to pick back up on it. Again, that's part of the reason I record the lectures here. So if you are having trouble, please contact me. I will not be holding traditional office hours. Instead, if you need to meet with me, send me an email, and I will meet you virtually via Zoom. Right? So long as you've got a web camera or a microphone or something, I can meet with you. If you need to meet with me on campus, just send me an email and I'll meet you. The reason I don't see a need for traditional office hours is because you're stuck with me for 4 hours a day, twice a week, and 2 hours on Monday. So there's plenty of time, and the class size is small enough that I can get plenty of one-on-one time with you. Most of the labs are always going to be time for you to work on the homeworks I have assigned. So your homeworks are basically your labs, and your labs are your homework. There's no difference between them. Okay. So our topics we'll learn about generics. Hopefully, so how many of you took 1068 last semester? Right. You did. When did you take the prereqs for this course?
1068 was, I think,
last summer. Okay. So you still, what did you learn during 1068? Did you learn about inheritance? Did you learn about polymorphism and inheritance?
That sounds very vaguely familiar, and I'll just read the beginning.
For how many of you is polymorphism vaguely familiar? Because that gives me the starting point. Okay, great. So I know exactly what my lecture is going to be today. No worries there. That's all I had to know. I just need to know where I'm going to start off and what our first assignment's going to be. That's really it. But if you guys, so we're going to start off with inheritance, and then we're going to talk about generics and array lists. Now, how many of you have worked with array lists before? Okay, so you have because Dr. Fiore started putting it in last semester, right?
Just to clarify, like it wasn't on the exam.
Right.
At all.
No. I'm going to teach it as though it's the first time you're exposed to it. And I don't think he used, did he use generics as part of that, like array lists of integers, or did he just, or did it have a bunch of errors or warnings when he would use it?
No, they still went array lists based on data types.
Gotcha. So, okay. Yeah, so we'll learn about how to use generics a bit clearer like that. We're going to specifically learn about different ways to organize our data. So we're going to learn about lists, okay? So we are going to learn about lists, which are a standard data structure. you can have either array lists or you can have linked lists, and since we have two different types of lists, they're good at two different types of things. We'll go over stacks and queues as well, and our first exam will either be after learning linked lists or stacks and queues. Mainly because linked list is the point where basically that if you're understanding the stuff, if you're understanding linked lists, you'll do fine in the class. If you are stumbling on linked lists, you'll have, then you know you need to do better. So it's a very early warning. I like to have a very early warning as to how you're doing. Stacks and queues are fairly simple. That'll go by pretty quickly. We'll then teach recursion. Recursion, if you've done it before, we go in a bit more depth. We learn a strategy called recursive backtracking. And we're going to be solving some popular puzzles there. Then we'll learn about binary trees and heaps. We'll probably skip Huffman trees, just simply because of, it's summer and time is an issue there, so we might skip that depending on how much time we have. Sorting algorithms, I generally go over like 7 or 8 sorting algorithms, depending on how many we have. That might get condensed down to the 3 you need to know. And then we'll go over hash tables and basic graphs. So those are a lot of that. Now, typically, what I've done in the past semesters is that I have a YouTube playlist of flipped lectures, right? And the idea is that behind a flipped lecture is that you will basically watch the stuff before coming to class. And this was fine for a 15-week semester, where basically it meant every week you watch 2 hours of video, right? And then you come into class, and rather than me lecturing, you got the lecture time to work on the assignment. So, anybody see a problem with that for the summer? A little bit, right? It's that would be 6 hours of video a week, right?
Sorry to interrupt, but I mean, if we're going to be having lab projects anyway, then it would just be 6 to 10 hours of lab as homework.
Right.
It's not really different.
And it really depends on how you guys feel about it, though. I don't know how you feel about watching these videos on YouTube. Because if you do, I could just simply, starting on Wednesday, I could start flipping it if you'd want me to. Otherwise, and then basically you'd get 4 hours. Then you'd get basically 10 hours a week to work on your assignments with me helping you. So I don't know how you guys feel about that. If you guys would prefer to do it flipped or not.
Personally, flip sounds good.
We wanted to try it out.
Yeah.
Okay.
It's new.
Okay.
For 6 weeks.
So,
Could you just briefly explain exactly what you mean?
So that means that basically that I'll assign you videos starting on Wednesday, starting tonight, to assign you videos to watch. It'll be about 2 hours of video. It'll be about an hour of video for every hour of lecture we have here. So 6 hours a week. But what you get in exchange is that you don't listen to me drone on basically in here. Instead, what I do here is that you are going to instead be use this time to work on all the homework. So the objective here is that rather than bashing your head against an error and trying to email me, and then me trying to email you back and then trying to arrange a time to meet, instead of getting 4 hours of lab time a week, you essentially get 10. And the idea here is you do nothing outside of of class other than watch the videos, ideally. The other thing is that I'm very big on people working together. You are more than welcome to work together for your projects. Now, the big thing here is that the way I handle homework being turned in is through a process called demoing, where basically you show me and I ask you some basic questions about it, and then I check it off for you. This is because, to be honest, downloading when the class is about 400 people large, it's hideous to download something. We don't get 400 people classes, but even with 40 people, it's a bit hideous to download and run. Oh, you have it in a different package than what I was expecting, so I have to move it now, and the like. So instead, you just run it, you submit it, and then you run it for me. More on that later. But basically, for most projects, you can work together and you demo it individually. Okay, that way, so long as that way everybody understands what they're doing. So we'll try the flip thing out. If it turns out to be a horrible mess, we can always stop, right? So I have an entire, so as far as that's concerned, the playlist should probably be on YouTube at this point, is already there. I will probably go over the first videos in class today. Okay. And I'll have to update this for the actual stuff. We are using the Data Structures textbook by Elliot Kaufman and Wolfgang. I don't care what edition you have, but the 3rd edition I found is cheaper. I also don't care, where you get the book, so to speak, So, I pretty much try to cover everything in the text, most of the things in the textbook, though. So, again, I have to revise this syllabus for this class, which I'll be doing this afternoon. There is no TA. You've just got me, which is great because I've just got you guys, and there's supposed to be 9 of you. But hey, if there's only 6, then that's great. Means more time for you guys. You again, do try to be here. This is super accelerated, so be here, right, during class time. If you're not here, then I can't help. Then it's going to be very hard for you to succeed. I know it's going to be early in the morning. I know that's going to be an issue sometimes. If you're running late, just let me know, okay? But I have a toddler at home. I will be here. If I can get here, you guys can make it, okay? Similarly, though, if you're sick, just stay home. No worries. If you need me to spend personal time with you to help catch you up, I'll meet you via video chat, and I will basically make sure that you understand the concept and answer your questions. Okay, right? Don't plagiarize, right? If you need to work with me through DRS, let me know. Also, I'll be recording. That's just simply to let you know if you ask a question, it might be captured in the recording, and but I'm not going to spin it around and put you on camera, so don't worry. Okay. Grading. Typically, you need above 70 to pass the class. Typically, the way that grading works is that quizzes, which often have a participation grade baked into it, right? Those are 10% of your grade. And those will just simply be simply review stuff of the video. There'll be multiple choice. And oftentimes I'll let you do that stuff. Labs and assignments are worth 25% of your grade, and then your exams, we'll do either 1 or 2 exams, and depending on the time. Again, I haven't taught this during the summer yet. Typically, I do 2 exams and a final. But if we need to do just 1 exam, I'll up the amount that the quizzes and the labs are worth in order to make up for the rather than increasing the amount that the final is worth, because I really hate high-stakes stuff. The quizzes will be electronic on Canvas, so you'll need a laptop or you'll need or you will need a phone, and you will need a laptop for this class. Basically, starting, if we're going to do it flipped, you're going to need a laptop for this class. Does anybody here not have a laptop they can use for programming? Because I have a spare laptop at home, if you need to borrow it. Okay, just let me know for that. Right. This is just simply the demoing process. Again, I explained the demoing process to you guys already, which is just simply when you're done with your work, just come up to me during lab or lecture or video chat with me, and show it to me. So I have a very generous late policy because it's very easy to fall behind even when it's not summer, right? So my late policy is as follows: submit your assignment. So long as what you submitted is what it matches relatively closely with what you're showing me, then when you submit it is when it's counted as you turned it in, right? So you submit it, and then you demo it. So you submit it the day it's due. You demo it after it's turned. It's fine. It's not late, right? Demoing it, you're not late based on when you demo, but when you turn it in, okay? And if you have to make a quick fix because of something, then it's still not going to be late, okay? as far as my late policy is concerned, it is your score times 0.95 to the days late. So it's kind of an exponential decay with a cap of half credit. So once it gets to half credit, it's not going to get any lower than that. Okay. Also, I'm very, very reasonable about this. Like, say you've got a homework that has like 6 parts to it, right? Or sorry, let's say 5 parts, because that makes the math easier. You do 4 parts on time, but the 5th part is late. Then only that 5th part is going to be counted as late. Okay, so I try to be really, really reasonable about this. Okay, so other stuff, yeah. Normally it's week 5 and week 10 are your exams, which means that basically we'll have our exams probably, end of the 2nd week and end of the 3rd and end of the 4th probably. Possibly. Might be the beginning of the 3rd. It just really depends. But otherwise, it's fairly straightforward. Okay, so as far as the first videos are concerned, let me go ahead and pull up my Canvas page and see, because I just simply imported everything from last semester and in the hopes that would work out. So let's see if that worked out. So I try to keep everything on Canvas. And I'm going to set up a new GitHub repo for you guys. No, canvas.temple.edu. I try to host all my code on GitHub. And there should be a link to that. Let's see, data structures. Oh, great, it did transfer everything, including the icon. So yes, it turns out you can actually put a GIF for your class icon, right? Which, anyway, so let me go ahead and now that I know what our first assignment is going to be, hold on a second. I thought I unpublished everything last night.
I couldn't see anything.
Yeah. Okay, there we go. Yeah, okay, I just clicked on the wrong course. So there we go. So I will publish the first couple of, I'm going to publish the first couple of assignments for this week, okay? So, so there's an extra credit assignment here first off, which is why not take the time to teach yourself regex? That can be turned in at any point before the end of the semester for 10 points of homework. Similarly, another way to get extra credit is if you find mistakes on my videos, please point them out. Each mistake is worth 1 point on your exam grades. And you just have to find something that somebody else hasn't found, and you just leave a YouTube comment for that to claim it, okay? So no worries there. Okay, so you should be able to see that. Under pages then, all the video, so first off, there's 3 links under pages. This is where most of the useful information is, under pages. First is this link to Crash Course Data Structures, which is a fantastic, if you aren't familiar with Crash Course, it's a fantastic YouTube channel. This is 10 minutes of a 10-minute overview of all the concepts you learn in the course. In 10 minutes. It's amazing what you can do when you have an entire team and a script. Next is a link to the code. All the code that I've done in the videos can be found under destruct for data structures. And there's all the source code. So if you're madly trying to type stuff along or you need to find it, it's under there. So, and the third one is lectures. And I just need to edit this page. But here is the actual YouTube video. And again, it's roughly 2 hours a week, but I'm gonna, an hour for everything. But I think I'm gonna try to go over as much as possible today. And then I'll let you know what you need to, and then by today I'll let you know what your goals are for the week. Okay, and if it ends up being too much, you let me know, and we just simply transition smoothly to be a regular class. Okay, you'll find the quizzes under here. I'm probably actually going to redo a lot of the quizzes to be a lot nicer. And full disclosure, a lot of what I'm doing over here, I'm going to be working on redoing so that I can make a much better version of so I can implement these things in a graduate version of these course. this course. I actually already have implemented it, but there's actually a lot of nice videos we got, which I'll probably actually grab and might insert for you guys. So, all right. So, with that being said, let's go ahead and talk about your first assignment. Okay, which is Fox and Rabbit. This is typically what I've given as a final assignment for 1068. And it is a review assignment, but it is fairly good. It is you will download this PDF file to run the program. And I've totally stolen it for somebody else. And it's fairly straightforward. Okay, save. I'm going to go ahead and save this file, and I'll unzip it and run it for you guys. And then I'll get into the lecture. So extract here. Let's go ahead and copy it, and I'm going to go ahead and paste it into IntelliJ. I really enjoy using IntelliJ, by the way. It's my IDE of choice. I don't care what you use, by the way, but I like IntelliJ because of its auto-completion and stuff. Okay, so there we go. Cancel. Okay, so here's all the files that. So it's a whole bunch of files that you'll just want to copy into your IDE, and it looks like a lot, and it is. Okay, but actually your goal. But it's pretty easy to see once I actually run this. There's two runnable files in here: the grader and Rabbit Hunt. So let's go ahead and run Rabbit Hunt and see what it does. Okay. So it's just compiling right now because it's a fairly large project and it's trying to analyze it. And believe it or not, it's a working program. You don't have to modify too much for it. Okay. So here we go. And you might get a blank screen in the beginning if you're running a Unix-based machine, but that's okay. So you just hit the run down here and it will run. And anyway, so this is a field. It's bounded. It's not like Pac-Man. You can't go off the edge. Now this red dot over here is a very, very hungry fox. And this yellow dot over here is a very unfortunate rabbit. And when the fox gets to the rabbit, it has a delicious lunch in the form of the rabbit. Okay, it says that, and the fox is able to, and so this game is played under a certain number of turns. So step number 1, 2, turn 3, turn 4. And so the goal is as follows. If the fox gets to the rabbit, he wins. If the rabbit evades the fox for 100 turns, he wins. Okay? You are going to play as the rabbit. Okay? So, and the rabbit because the rabbit has an AI which is honestly not that great, which simply says return random min direction, max direction, which simply means move in a random direction, which I'll explain in more detail about what these mean. But yes, it just moves randomly. This is not good for its survival. In fact, if I were to say, in fact, its survival rate actually improves slightly if I tell it just to stay still. If I run the grader, it will just simply run 300 versions of this game, and it will tell you it was able to escape by being completely random. It escaped 4 times out of 300, or it survived 1% of your time. Your grade for this assignment is the percentage is based on a square root curve, which means that it's the percentage of times the rabbit survives. So the square root of that percentage times 10. So if it survives 81% of the time, you'll get a 90 on that assignment. You get 90 points. And then you get 20 points for demoing it. This is one of those assignments that you can work with another person and demo it with another person. Okay? So it survives 4 times out of 300, so 1%. So square root of 1 is 1, times 10 is 10. This means that a 64% survival rate gets you an 80 on the assignment, demoing plus 20, so there's a grand total of 120 points on this assignment. So this is one of the assignments out of 120, just simply to give you a bit of a buffer to begin the semester with. Okay. The goal is to modify. So the only rule is you can only modify rabbit. You can't modify anything else. You can only modify the rabbit class. And specifically, all you really need to modify is the decide move function. You can actually come up with a very, very powerful and a very easy, good strategy to survive in, just by having like 10 lines and using some observations. I'll explain the observations before we let out for class, and then I'll let you maybe program it, play around with it a bit tonight so you can get everything set up. And then when you come in on Saturday, you guys will work on, not Saturday, tomorrow, Tuesday, you'll be working on it. And I'll send out, I'll give you guys, and right now though, I'll go forward and try the lecture. But the nice thing about this is that it uses inheritance, right? Let's see if I can actually skip the first lectures just by simply going over the homework. So public class rabbit, it extends animal. That establishes an is a relationship between the rabbit and the animal class, right? Okay, so everybody remember that concept of inheritance in Java? Does anybody not know that concept at all? This is completely new to them. But everybody vaguely remembers this, right? Vaguely, and I do appreciate that it is a vague remembrance because it may have been a while ago. Okay, so rabbit extends animal. That means that a rabbit is an animal. There's two relationships you can have with objects in Java. You can have an is a relationship and a has a relationship. A rabbit is an animal. Okay, so an animal is just this class with a bunch of stuff in it, and I'll go over that stuff in due time. Similarly, a fox is also an animal. This means that the rabbit and the fox can do anything the animal can do. So any method that animal has, a fox can use it and the rabbit can use it. And this can go all the way down, right? Right? I could have a super fox, which instead of moving 1 square, moved 3, instead. Okay? Or something like that. The bushes, the green spaces, are just simply that, right? Doesn't really require anything. Now, this is using, this is a very good example of object-oriented programming. Basically, everything is in the program is defined between relationships between everything else. Which is to say that we are using, and specifically it's set up in what we call a model view controller method of programming, which is a GUI, which you will probably you haven't heard of yet. But it's very well established, and this is a way of just having of handling graphics. So you have the model, which is the internal view of the program. So in other words, this is the field that you're running in, right? It's an array of objects, 2D array, right? Makes sense. It was a 2x2 grid. The number of rows, number of columns. There's going to be a rabbit. Here's the variable for the rabbit. Here's the fox. Here's the positions for each of them. Also notice they're private. This is the concept of encapsulation. We don't want the rabbit cheating and basically reaching in and looking at what the fox's position is, right? I'll explain how they find each other. Right? Final int, the number of steps. This basically specifies the internal structure and logic and rules of the game. The controller is fairly straightforward. It's all those buttons I was pressing. The start, stop, step, and the dial. Basically the user input. And the view is what the user sees. Right? It's and that's responsible for drawing what the model represents. So by splitting it between those things, and then we can make it easy. And then everything else we have is just simply what we call an actor. Right? These guys just simply live on the model. So let's take a look at what an animal. So first off, they have a model, right? They have a reference to the model, okay? So that they're a part of. They have their position, int row and int column, right? And then they also have a constructor, right? All things have their constructor, right? Simply given a model, row and column, it will set up to be a model, row and column. Don't have to really understand much of what the model is. And then it's got a bunch of utility functions, these static functions. So you've got the random function, which returns a random integer between two values. And then it's got this look and distance function, and a can move function and a decide move. All right? So the decide move is fairly straightforward, and we override that, right? Overriding means what? We simply take our parents' behavior and we give it our own behavior. If we didn't override it, then let's go ahead and modify Rabbit so it doesn't override its parents' behavior, right? So now when it tries to decide a move, which is how it figures out where it's going to go, is everybody following me so far? I just want to make sure I didn't lose anybody yet. Then Rabbit doesn't have a decide move function. So how's it going to move? All animals need a decide move function. Well, it will use animals' decide move function, which is stay still, which is not good for its long-term survival, right? It's just stay still. Okay, so so we want to implement override decide move in order to win at the game. Okay. So let's see. So let's take a look at how these things work. So looking at the model for just a second, notice that we have these integers over here. Define some class constants to represent directions. So directions, right, there are 8 directions in the grid. You have north, south, east, west, as well as the 4 diagonal directions. Northeast, southeast, southwest, east, and northwest. So we let 0 be north. So it goes around clockwise. 0 is north, 1 is northeast, 2 is east, 3 is southeast, 4 is south, 5 is southwest, 6 is west, 7 is northwest, and 8 is actually stay right here. Don't move at all. Okay? So the min direction and max directions are 0 through 7. But again, remembering like, oh, south is 4, that's hard. And programming should not be hard, or at least you shouldn't make it harder on yourself. So instead, we use these constants, right? So that way I can say if I want to be north, I can say model.north, model.n to move somewhere. Also, we have integers to represent each of the, to give us a signal for detecting things. So if I want to detect an edge, like the border of the playing field, I've got 0. If I see a fox, that's a 1, a rabbit's a 2, and a bush is a 3. So let's take a look at using this. Now I can, so how do I basically how do, so let's now that we have that, let's return to this. All animals have a model.look, which given a direction, right, 0 through 7, it will look in that direction and return the first thing it sees in that direction, right? Does it see the edge, a fox, a rabbit, or a bush? And then paired with it is the distance function, which is because you can only return one thing in Java, right? So here it will return the thing. It will return it returns an int because remember, a integer, like we use a 0 to represent the edge, a 1 to represent a fox, a 2 to represent a rabbit. You don't have to remember what goes to what. You can just use model.bush or model.edge. Distance gives you the distance to what you can see, right? So use this to see if you see something, and then distance to figure out how far it is. And then can move, which you probably don't need to override. In fact, you can see over here because it's super useful. You don't need to override any of these functions. Decide move is really the only one you need to override. Can move just simply says, is that a legal move in that direction? Can I legally move in that direction? So let's go ahead and take a look at a fox. Now, it's good for understanding how this works and what the fox is going to do to us, do to our poor rabbit. But I will tell you, just simply having watched 3 semesters of students try this, you do not want to try to like reverse the fox code. This is the code for a predator. It is much more advanced than the code for prey needs to be. The only thing the prey needs to do is avoid. The predator needs to chase and need to search. Prey is fairly simple. Prey has two options when being searched by a predator. What are those two options in general, like in real life? Run or hide, right? Fight is not an option here, right? Fight is not an option here, but run or hide. So hiding is pretty easy. Get into another position and stay still. Running is also fairly easy. Go a direction away from that thing, preferably in a direction that will make sure that I can't see anything. Hiding is fairly easy. If he can't see me, then stay still. So the fox has to look for stuff. So he set up a bunch of instance variables. Have I seen the rabbit? Can I see the rabbit now? Distance to the rabbit, direction, and the current direction I'm going. And the current direction gets set up as a random direction. So what the fox does is that it's nice and commented here. Look all around for the rabbit. Can I see the rabbit now? He says it's false until he can prove it's true, right? And what he does is he says for int I, starting from the min direction and going less than or equal to the max direction. So this is the first thing I also have to point out that's interesting about what I've done here. Notice that your less than or equal to sign actually looks like a less than or equal to sign. This is because of the font I'm using. I'm using Fira Code, which is a nice font that has ligatures. And so what happens is that when I combine two symbols that can be combined, it combines them into a nice looking symbol that makes it easier to read. Notice it actually takes up two spaces. So this is just simply a feature of my thing. I'm not actually using a weird symbol. You can also notice it kind of over here with the plus plus symbol where the plus pluses are actually touching. Okay, so model.max direction. Same thing with the double equals over here. It just looks like one big equal sign. Okay, so it's basically saying I is all these different directions. If I look at all the different directions, and if I see the rabbit, then I said I can see the rabbit to true, and have I seen the rabbit to true. Then I set the direction to the rabbit to be I, and the distance to the rabbit to be I, right? So I just simply look around me. Now, if I run rabbit hunt again, we can and run it step by step, we can actually see the look function activate because it actually draws. Okay. So let's go ahead and run. And so if I run it step by step, those yellow dots that are going out, that shows the look that the rabbit, that the fox does. So see? And if you use the look function on our rabbit, he's going to do the same thing, right? And notice that basically he just looks in various directions. This gives us a first key about maybe how our rabbit's going to survive, which is that notice that basically the he can't look first through bushes, which is useful. You can't step through bushes either. But notice that basically for this fox, he looks in this diagonal, and then he looks down, which leaves this giant cone out here, which he cannot see. Right? Just the nature of the way the map works and the way vision works in this scenario. Unless you've got a direct line to you, you can't see. Also, the turns are asynchronous. So he looks and moves, and then the rabbit goes. Mind you, remember, the rabbit doesn't do anything because we told it to do nothing. So it's possible so here's our second observation. It's possible for the fox to look, not see the rabbit, and move. And then next turn he would be able to see the rabbit. And if the rabbit then moves out of that position, then great, the fox will never know he's there. So anyway, then what he does is, so after looking, he says, hey, if I have seen the rabbit and the distance to the rabbit is greater than 0, right? If I've seen the rabbit, my distance is greater than 0, I'm going to move to where I last saw the rabbit, right? If I see him, if I have seen him, I just chase him down, right? And if I get to the spot where the rabbit was, right, it doesn't matter if I can see him now or not, because the rabbit might have moved. And if he moved, well, if I get to his last known position, I should be able to see him again, right? But if I don't see him, then I set have seen rabbit to false, and then I start wandering again, right? Notice that if I get to the rabbit, I just simply, if I can see him, I simply go. Otherwise, I start choosing a random direction to move. And then I ask if I can move that direction. If I'm just wandering because I can't see the rabbit or I've lost him, I ask if I can move in this direction. Then I just move in this direction. Otherwise, and this is a very important function here, the model.turn, which says, basically, which gives you a 45-degree turn. So this says, so for instance, if current direction is north, this will be northeast. This will ask, can I move northeast? If I can move northeast, go northeast. If I can't go northeast, try northwest. If I can't go northwest, I'm going to go northwest. So the model.turn is very useful because it allows you to say, this is the current direction. So if I want to say the fox is over here, I'll show you. Say the fox is over here. I want to go that way. Generally a bad idea just to go directly away, but I can do that just by saying model.turn 4 from the direction I see the fox. And if I can't move in any of those directions, I choose something random. Okay, so let's go ahead and just do something basic with the, so we're going to do something super basic and super suicidal for the rabbit right now, which is fairly straightforward. I'm going to look in all directions for the fox, and if I can see him, I move directly away from him. This is not anything I ever actually suggest doing. In fact, most of the time, it's best to stay still so you don't accidentally move into the view of the fox. Okay, so how do I do this? Well, for int I is equal to 0, or rather model dot min direction through model dot max direction I plus plus. So now we've got, this will give me all my directions. So now what I'm going to do, I'm going to say, I'm going to look. If look in direction I is equal to a model dot fox. And notice I'm not even going to bother making any memory or instance variables for this guy. This guy is just going to be completely reactive based on what's going on. Then I'm going to return model dot turn I, so the direction the fox is in, and 4, which is 180 degrees away from, right? So this is a number of 45-degree counterclockwise turns you want to make. Right? That makes sense to everybody? Or sorry, the number of 45-degree clockwise turns that you want to make. So it's easy to see when I run it what will happen. So this will move 180 degrees away, away from the fox. In other words, it'll move directly away. Model dot. Otherwise, if I can't see the fox, I'm just going to stay there. Okay, so run. Okay, so now step. So now I'm going to show you guys with the step, using the step function, right? So now notice the rabbit is looking around for the fox, and he's just simply staying put. Now the fox looks, and so now we're going to run. Okay, and so the fox is moving, he sees him, and now notice what's going on. So notice that so I'm going to stop right here. Notice that the rabbit was moving away from you notice that the rabbit, once he saw the fox, he moved away from the fox. But now, he can't move any further away. He's at a wall. And so now, he can see the fox. He says, move this way. He can't move that way, though. So he's just going to, it doesn't crash the program. He just stays still. So he's going to get eaten. So if 37 turns in, the rabbit gets eaten. So, obviously, so moving away doesn't necessarily work, though, as a strategy for the rabbit's survival. And the reason for that is that it doesn't break line of sight. Right? As soon as the fox sees the rabbit, right? It's as long as the rabbit keeps moving directly away from the fox, you're never going to break line of sight. This might actually work out. This will actually work out fine for the, see? So can't break line of sight. And the rabbit needs to break line of sight. So now let's go ahead and say, rather than moving directly away, I'm going to move away at an angle. Rather than moving directly away, I'm going to move away at an angle. And so if we run this now, see what happens. I think actually we're in a very good position for, okay, so this is going to be poorly for us, but, oh, notice that. Got really close and it never saw him. And the reason for that is that, remember what I said earlier? The fox is going to move, and the fox looks before he moves, right? So he looks, and then he determines where he's going to move. But you can't look after you move. So what happens? He looks, and he moves, and basically, so the fox moves into line of sight of the rabbit without having seen the rabbit. The rabbit sees him, moves out of the line of sight, and so now the fox never even knows he was close to the rabbit. So if we actually run this on grader, just this, if I run this on the grader, to see what grade this code would get. Again, and it runs 300 trials of this. Let's run grader. It escapes 19 times, or 43%. And why? Now, it actually has only a 20% success rate. If we run it's actually a pretty volatile amount of times. So 54. And the reason for this is because eventually it's just going to get stuck, right? Sometimes I'll have a bush to the diagonal. And if I moved in a different direction, I'd be able to go. So if you have a bit more if statements, like if I can move this way, I move this way. Otherwise, I try moving this way. And if I can't move this way, then I try this way, right? Sometimes it might even be beneficial to move diagonally towards the fox. Sometimes. I don't know. But if by staying still, unless you see the fox, that actually can get you into really high percentage survivals for this. So any questions on this homework assignment so far? Yes?
Yeah, are we supposed to just keep going through the code to find all the commands that we can use?
I have so all my files, every one of my assignments has a PDF associated with it, which tells you how to do this and the directions to it, right? And then over here for the mod, I tell you where it has, but also here's a lot of all the constants. And then model.turn is really a useful one. Really, you just need look and model. You need look and model.turn, and that should get you in anywhere between depending on how clever you can be with it, somewhere between 70 to 80%, I think, survival rate. If you use model.distance to make sure that you stay away from the edge, because of course if you get too close to the edge, you can get cornered in the edge. Mm-hmm. If you use that, then you can get into the 95% survival rates. But again, because of the square root curve, you're going to have diminishing returns, right? And that's deliberate. I don't want you guys to spend necessarily too much. This is a review exercise. And the idea here is take something that's not broken, right? Don't break it further, but make something, because a lot of times you're going to be working with existing code bases, right? You're not necessarily going to be writing something from scratch. So this is one of those times. Okay? So the only thing I want to discuss here before we move on is the concept of polymorphism, because we didn't really we haven't really talked about that too much, and it doesn't get used too much over here. So I'll need to just start a new, let's go ahead. And I'm just going to write a random file over here, right? And I'm going to just, I'm going to use a new project for this, but I'm still going to use the animal examples because I found using the animal example really makes this useful. I'm going to call this My Zoo as my project. And it's going to be a pretty boring thing, okay? It's just going to be about animals and the different ways they eat. But I found that this example, and this is the example I have in my videos, but you won't have to watch this because we're doing it in here. So I'm going to make an animal class that will act as a super class for a lot of things. Now, animal by default, right? If you don't put in an extend, it automatically will extend the object class. Do people remember that? Right? So I'm just going to make it fairly straightforward. All animals have a name. I'm going to go ahead and make the name private, right? I'm going to go ahead and do people know what the difference between private and protected is, by the way? Okay, so private means that my child classes can't see the name. So we'll change that in a bit. Okay. Private string name. Okay. Let's go ahead and make a constructor. I'm going to go ahead and be lazy about this and let my IDE handle it. Right? You can generate code. Alt insert generally does that. So I'm going to generate a constructor. And ta-da, public animal string, right? Given the name of this animal, it's going to do that. Public void move. By the way, is the font size good for everybody, or do you want me to up it? Okay. Public void. It always depends on the room. Okay. Public void move. Okay. Sout. By the way, if you're using IDE or if you're using NetBeans or IntelliJ, SOUT tab, system.out.println. SOUT tab. Okay, so you're in 2168. You're learn to use your IDE and don't be afraid to use it. It's not right. You've passed the point where this would be a crutch. Right now, it's starting to be a tool. Okay. So now I'm going to say that this dot name plus moves generically, right? Because it's just an animal. We don't know what kind of animal it is, so it's just moving generically. But we're establishing that all animals can move. And I'm going to create an eat method over here, string thing. This dot name eats plus thing plus generically, right? Also being generic about that, right? So if I create a, so I'm going to go ahead and just create a new class over here I'm going to call it playpen, just because I'm going to play with the animals. And watch another shortcut over here using NetBeans or IntelliJ. Eclipse doesn't have this. I don't know why. It's so valuable. Public static void main, PSVM, tab. Okay, it's like magic, right? PSVM tab. Okay. Next thing I'm going to do is just simply create an animal. Animal Alice. No, I'll use my name. Animal, and so animal A is equal to new animal Andrew. Typically we use Alice and Bob as the typical name. Notice that, by the way, that this came up name colon in gray, and it's not in monospace. This is just a helpful reminder of IntelliJ saying this is what the argument is, right? What the name of the variable that you're putting in is. It's the name. Okay, and then I'm going to just call a.eat lettuce. Okay, and now, how do I, here we go. So now it's building it. And it goes slightly slow because I'm both recording this lecture and I'm running something, a heavy-duty IDE. So Andrew eats lettuce generically. Okay, great. So let's go ahead and make some, I'm going to make some children classes. I'm going to make a reptile. And I go through this example in more detail in the videos, but I've honestly covered a lot of the bases because we went through the homework. So a reptile is an animal, right? Extends animal. We established that relationship there. Why am I getting an error? Let's find out. There's no default constructor available for animal, right? The idea, you get everything from your parent but your constructor, right? So we need to have let's go ahead and make a default constructor over here. Public animal, right? You can have multiple constructors. If I don't give you a name, if I don't give him the animal name, I'm going to say this.name is equal to Andrew. And everybody understand the difference between this.name and name? Or is that something you need a refresher on? Okay, so local variables so there's three types of variables. There's static variables, local variables, instant variables. Static variables are super easy. They have static in front of the name, and they exist right up here typically, right? And that means that you have one copy for every that is shared between every member of the class. So basically, if you have so for instance, math.pi has a static variable called pi, which means that basically there's only one pi if you were to create a bunch of math classes. You can't actually create a math class, but that's okay. A math object, but that's okay. But if you could, they'd all share one copy of pi. Okay. Similarly, you also have instance variables. Each animal has its own name. They're these things that are up here, right? Private string name. They typically have an access modifier, such as public or private, in front of them. And finally, you have local variables, which are passed in as parameters, or they're created on the fly, like int x, right? That's a local parameter. X is equal to 5. Notice the color difference, by the way, in my IDE, where the instance variables are red and local variables are black. Okay? Local variables just exist for the duration of the code block they're in, such as the method or the loop. Okay? Now the this.name, so it's possible to have a local variable named the same as a instance variable. That's perfectly legal. So the question is, how do you tell the difference between the two? And the answer is that if you don't specify, Java's just going to assume you want the local variable name. Okay? But what you can do is that you can use this dot to say this object dot instance variable name to get it. So this says take the local variable name and store it in the instance variable name. In fact, it's good practice that whenever you're using an instance variable to use this keyword. It's a good habit to get into. If for no other reason, then you can just use autocomplete then to use it. Does that clarify?
Is that like the same thing as global variable?
Static is more like a global variable. Instance variable is basically every animal has a name, but this is my name, right? This is my rifle. There are many like it, but this one is mine, right? So it's global. It's kind of global for that instance, but a static variable is closer to what you would see with the global, where it's global for every instance. So anyway, I'm going to go ahead and create a constructor. Okay. By default, if I don't have a constructor, I just Java provides one, right? If I don't provide a constructor, Java will provide one, which looks like this. Cancel, I don't want to power off. Okay. If I don't provide a constructor, Java provides one, which looks like this. Public reptile, reptiple. I swear I know how to spell, but I will mention that I did get my PhD in computer science and not in English, so you know. All right, public reptile. Okay, Java provides a constructor that looks like this, except that's not the end of the story. Because notice that if I go into here and create a reptile, first off, I can't use this because it doesn't have a constructor to take in a name, but that's okay. If I run it now, it's going to it's going to say, again, Andrew ate the lettuce generically. Andrew eats the lettuce generically. And the reason it does that is because actually there's an implicit super call. Super being a keyword that we're never going to see again, but it's important to understand there. Super just simply, so is everybody familiar with the concept of using this? Like so. Has anybody ever seen this? If you haven't, don't worry. But this is basically, you can use this as a constructor to call another constructor. So this simply says, animal pass Andrew to this constructor. Okay, pass Andrew to the constructor with one string variable. Make sense? Okay. Similarly, super means call my parent's constructor. Super with no parentheses means super with no arguments means call the animal parameter that takes in no arguments. Okay. So okay, we've got reptile, super. Yeah, that works out. Okay. Sorry, I was just thinking for a second what the schedule for classes are going to be. So I think now that so next week, I think what's going to happen, for the rest of the week, tomorrow we'll do the fox and rabbit. So you'll have 4 hours to work on the fox and rabbit pretty much. And then on Thursday, we're going to do array lists. And then on Monday, because it's a shorter thing, we'll be working on big O notation, and we'll do the big O worksheet here. And then, yeah, this will work out really well. Okay. All right. And you came in late, so you missed the whole thing about the flipped lecture, so I'll talk to you after it. So no worries. Okay. All right. So we've got ourselves a reptile. Obviously, we want to try. So anyway, that's all I have to say about super. Just remember that basically you're going to call your parent's constructor. But let's go ahead and set up a, let's say, a public reptile string name over here. And I'll say this dot name is equal to Ralph. And this is where we get, this dot name is equal to name. And this is where we get into our first issue, where I say this dot name, right? It's an animal, so it has a name, right? Because animals have names, but it can't see it because name is private. Everybody understand? Can't see it because name is private. But if I make it public, that means everybody can see it and everybody could change my name. Don't want that, right? So the word we use in those cases, you might see, is protected, which is only used when we use inheritance. And protected means private to just me and my family. Everybody in my family. Me and my children. So I can see it, and all my subclasses can see it. So now by making it protected, I can do this dot name is equal to name, and then I can say this reptile. If I don't give it a name, it's just going to be Ralph, right? And so if I run playpen, Ralph eats the lettuce generically, right? But actually, let's go ahead and just go ahead and say reptiles, though. Honestly, reptiles eat more with a crunch, so let's go ahead and override our parent's function, right? Public void eat, so we're going to implement this a bit differently. And what I'll say is sout tab again. This dot name I'll torture you with this example only for like 10 minutes or more, I swear. So this.name plus equals, sorry, plus crunches this dot thing. So not this dot thing, right? This is a thing is a local variable. Period. And so now, if we run playpen again, we call the overridden function. Ralph crunches lettuce. I'm gonna make I think 1 or 2 more classes, and then I'll get to the point of this. Okay. I'm gonna make a snake class. Okay, and fairly straightforward. Let's go ahead and again, I'm gonna be lazy and use the constructor. Public snake. I'm gonna go ahead and call the snake Sally. This Sally. Right, it's gonna say, hey, generate constructor and snake. There we go. String snake name. This dot name is equal to name. Okay. Oh, that's why I wasn't getting anything, because I forgot to extend it. Extends. So snake is an animal. Specifically, it's a reptile, right? So you can extend this chain all the way down. Okay. By the way, did you guys ever learn about interfaces? No. Interface? That's okay. I think I've got my videos for that, and that comes up more with array lists. So, all right. So, public snake string name, this dot name is equal to name. Okay, and it's a reptile, so it's going to crunch stuff. But snakes move specially. They're going to move. I'd say that basically that it should move. Sout. This dot name slithers away because snakes slither, right? That's the way they move. Why don't I go ahead and make one more? I'm going to make a lizard extends reptile. Okay. Alt insert again, constructor. Here I was able to be super lazy. Lizard will just simply call this Larry the lizard, sure. Lizard, and we'll override move, public void move. This dot, my bad, sout. This dot name, is it raining again? Darn it. This dot name plus scurries away. Plus. Okay. So the point of this is I needed a lot of classes with inheritance to show us about polymorphism, which is as follows: that you can have a more generic type on the left and have a more specific type on the right. So I can have an animal over here. Animal A is equal to a new reptile. Has anybody seen this before? Yes, you have. Okay. If you haven't, no worries. But basically, the idea here is I can use animal A, or I consider this thing on the left to be a box, right? This is an animal box. It holds all sorts of animals, right? It's a variable. It's a box to hold data. So the animal box can hold reptiles. It can hold lizards. It can hold snakes. It can hold elephants, if we were to make that class, and gorillas. It's shaped for all animals of all shapes and sizes and needs. But on the other hand, let's go ahead and say I make a snake box. Snake S is equal to a new reptile, right? I cannot put, this is a snake box. I can't put any reptile, just snakes into this box. Now the reason for this is that this is a more specific type. I'm trying to put a general type into a specific type. I might be trying to put a Komodo dragon in the snake box. That's not going to work, right? Komodo dragons are big. Snakes generally aren't that big. Make sense? Right. Similarly, if I try to do animal, that could be any type of animal. Can you imagine a blue whale trying to fit in the snake box? It's humorous, but it's probably not going to work. So you can't put a more generic type, more generic type into a more specific type. Now, it's an easy rule to remember, but what's the point? Well, the point is that polymorphism, this idea basically that we can treat, because reptiles are animals, because snakes are animals, because lizards are animals, we can treat them as animals at any point. The reason that is useful is because because we are dealing with collections of animals. So I can create an animal array. Animal, let's create a bunch of containers for animal. Let's call it a zoo, is equal to new animal. I'm going to create 5 boxes, right? 5 animals to be held in here. And so let's say zoo 0 is equal to a new animal, the default animal. Zoo 1 is equal to new animal let's go with Harry the hippo. Zoo 2 is equal to a new reptile. Zoo 3 is equal to new lizard. And zoo 4 is equal to new snake. So here's the cool thing about this. If I do a for loop for this, and specifically I'm just going to use a for each loop. Has everybody seen a for each loop yet? If not, I'm going to teach it to you right now. It takes 2 minutes to learn. A for each loop is like the Python loop, for loop, and it's super useful. For each animal, and what it is, it's for each thing in a collection of things. So for each animal A, so you put the type over here, animal A, because it's a collection of animals. In the collection of animals, we call zoo, and that's it. So and it will automatically iterate over them. It's useful when you don't care about the indices. If you care about the indices that everything's at, then you have to use the standard for loop. If you want to replace things or change it, then you got to use a regular for loop. But if you're just planning on going through it, just one item at a time, use the for each loop. Make sense? Right? You can't change things if you're doing a for each loop. Kind of you'll actually get an error. But anyway, it's pretty useful here. So I can just simply say a dot move, a dot eat yummy food. Like so. So here, and now here's what happens. Andrew moves generically and he eats yummy food generically because Andrew is an animal. And all he can do is just do the stuff generically. Harry the hippo is also an animal, so he's going to move and eat the food generically. Ralph is a reptile, so he moves generically because it just uses the parents method, but he has a method but he's got an eat method which specifies to crunch stuff. Now, Larry the lizard, his move says to scurry away, so that's what he does there, and he uses his reptile parents method to crunch things. Same with Sally the snake. Sally calls the parent's eat method, right? It goes up to the most specific eat method it can find, or the one closest to it, finds it, and calls it. Same with move. And it finds it has its own move method, so it doesn't need to call its parent. Any questions about this? All right. So we still have 45 minutes left to go. And as far as the videos for that would have been watched today, but you guys don't need to watch today because, you know, wasn't even sure if we were going to do this flipped or not. Okay. Let's go ahead and see. So flipped. So that was these 4 videos and the for each loop. So for tomorrow, you'll want to watch the videos on lists, if you can. Up through video 19 ideally, but that should be about 2 hours worth of videos. They're 20 minutes at the longest, and like they vary. So let's go ahead and actually just take a look right at the YouTube playlist. It doesn't actually look that pixelated. Right, so like if I talk about interfaces, that's 17 minutes, 18 minutes, 17 minutes. Honestly though, I've got some better videos. So I'm gonna go through this playlist tonight and start messing with it so you guys can see it, and I'll tell you what videos to watch. But if you wanna get a head start, you can start by watching these videos need to be watched by Thursday, actually. Thursday, because tomorrow we're just going to, by tomorrow you should watch these videos, but guess what? I just went over the content in the video, so you know you don't actually need to watch these videos. So if you can, try to get a head start and watch through video 19 by the end of the week.
Like 7 through 19.
7 through 19. It's broken up into 2 parts. The first part is how do we make lists and what can we use with them, and then the second part is how do you build these lists, featuring my awesome MS Paint skills, which actually later in the summer I plan on reshooting a bunch of these videos. But anyway, so for right now though, I'd rather use the time to basically go around, speak with each of you individually, get you guys set up on your laptops if you have does everybody have a laptop with them? Right? Get you set up on your laptop. If you don't have one, or if you need to buy a new one, I can talk to you about that and that kind of stuff. Okay, so and then I want to help you use the time to get started. Also, if you don't have a laptop, because this one is a partnered you can do the Rabbit assignment partnered. Partner up with somebody who does have a laptop.